Alright, so today we're going to be looking at triangles and trigonometry, okay? This is something we're going to be encountering a lot in our entire math career, so it's important to get it right. So, essential to this analysis is the trigonometric functions that we covered in their own dedicated video, but now we're going to see how they're applied to triangles in particular. So those are going to be sine, cosine, tangent, cosecant, secant, and cotangent, okay? So let's zoom in onto this little triangle I have drawn for us, okay? This is a right triangle. These trigonometric operations are only going to work on right triangles, okay? So these trigonometric functions, sine, cosine, etc., are going to be used within the context of a given angle, okay? So in a right triangle, we have three angles. We have the 90-degree angle given to us right here. Then we have some angle here and some angle here. For the purposes of this video, we're going to consider this angle, okay? Recall that all of the angles in a triangle always add up to 180 degrees. So if we know that this angle is 90 degrees, we know that the remaining two angles, this guy and this guy, will add up to 90 degrees. Which means if we know one, we will also know the other. Okay, so that's why you only need to know one of the angles in a right triangle. For example, if this angle here was 40 degrees, I would know that 40 degrees plus the other angle equals 90 degrees. Therefore, my other angle is going to be 50 degrees right here. Okay? So, back to the trigonometric operations. Sine, cosine, tangent, cosecant, secant, cotangent. They are going to give us information about the ratio of sides. Okay? So let's first name all of our sides to get a better understanding of this. We're going to call the longest side the hypotenuse. We're going to abbreviate that as hyp. The side that is adjacent to our angle or touching our angle is going to be the adjacent side. And the side that is exactly opposite our angle is going to be called the opposite side. Okay? So sine is you plug in an angle theta. Theta is just something we use to represent some angle measure, okay? So in this case, we're dealing with theta equals 40 degrees. So sine of theta, sine of 40 degrees, is going to equal the value of your opposite side divided by the value of your hypotenuse. Cosine of theta is going to equal your adjacent side divided by your hypotenuse. Okay? Tangent of theta is going to equal your opposite side over your adjacent side. Okay? And these are the three fundamental ones. The remaining three, cosecant, secant, cotangent, are sort of the original three but flipped over. So cosecant equals 1 over sine, secant equals 1 over cosine, and cotan equals 1 over tan. Therefore, we can write that cosecant equals hypotenuse over opposite. We can write secant equals hypotenuse over adjacent. And we can write cotangent equals adjacent over opposite. So basically what these trigonometric functions are telling us is if I have an angle of 40 degrees here, I'm going to plug in to one of my functions. Let's try sine of theta first. Sine of 40 degrees, if I plug it into my calculator, is going to give me 0.643, something like that. And what we're told here is that that is exactly the ratio from our opposite side divided by the hypotenuse. So in order to easily remember which goes on top and which goes on bottom and which ratios are which, we have a little acronym. SOH. TOA. SOH. Okay? That is what you need to remember. SOH. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Remember that and commit it to memory. SOH. So let me give you all an example, okay? Let's say I've got a right triangle right here where this side is 3 and I give you an angle of 30 degrees. Okay, and I'm asking you to find this side x, okay? So first and foremost, we need to consult TOA, and we need to find out which trig function relates our adjacent to our angle to the opposite of our angle, okay? So TOA. TOA has opposite and adjacent in it, so we're going to be using tangent of theta. So we know tangent of theta equals our opposite side divided by our adjacent side. And we know what theta is. Theta is going to be 30 degrees. So we're going to do tangent of 30 degrees equals x over 3, because our opposite is x and our adjacent is 3. Now we're going to go into our calculator and we're going to plug in tangent of 30 degrees, and we're going to get out 0.577 equals x over 3. Very often you will not be given the opportunity to use your calculator when you are doing trigonometric problems. And in order to solve that problem, I highly recommend you check out the video we do on the unit circle. That video is very helpful for committing all of the trig values to memory and being able to solve these problems without a calculator. So if you haven't already watched that, I recommend you go do so. Anyway, then, if we want to solve for x, we just multiply both sides by 3, and we get 3 times 0.577 equals x. Therefore, the length of our x side equals 1.73. So moving on from there, we have two general types of triangles that are useful to commit to memory and useful to be able to identify, okay? So we have one type of triangle that we call the 30, 60, 90 right triangle, where these are the angle measures, okay? So like we said before, a 30, 60, 90 right triangle is inherently a right triangle. One of the angle measures has to be 90 degrees, and one of the angle measures has to be 60 degrees, okay? So here is the dead giveaway. If you ever see a right triangle that has one of its angle measures as 60 degrees, you therefore know that the other angle measure is 30 degrees without even being told, okay? That's a good way to identify a 30, 60, 90 triangle. Also, if you're given 30 degrees, you can immediately know that the other angle is 60 for reasons already discussed. So the importance of this triangle is all of its sides are going to be in the ratio of x, 2x, x rad 3. And we can observe that in practice using our trigonometric functions. Okay, if I were to give us a right triangle that has side length 1 here and angle here of 60 degrees, then I'd be able to say, okay, what is this side going to be? This side is going to be, again, tangent, opposite over adjacent to my angle, okay? So I know tangent of 60 degrees is going to equal 1 over my adjacent. Now we know that tangent is going to equal sine over cosine, and we know that sine of 60 degrees is going to equal rad 3 over 2, and we know that cosine of 60 degrees is going to equal 1 over 2. So if we compute this division, that is therefore going to leave us with rad 3. Tan of 60 degrees is rad 3. So therefore that leaves us with rad 3 equals 1 over our adjacent side, or our adjacent side times rad 3 equals 1. Therefore our adjacent side here is 1 over rad 3. But wait, Meek, you told us that this would be 1 times rad 3. No, that's not what I said. I said that these are the ratios of the sides, okay? So the smallest side, x, is always going to be opposite the 30-degree side. Okay, and that's something we need to know about. So in this case, this is x, and this is x times rad 3. Because what do you get when you multiply 1 over rad 3 by rad 3? You get 1. Okay? Therefore, now that I know which side is my x, I know how to calculate my hypotenuse. It's just 2 over rad 3. The other type of triangle we're going to want to know about is the 45-45-90 triangle. And this triangle is a little bit easier. It consists of one angle that is, of course, 90 degrees, and one angle that is 45 degrees. And if one angle is 45 degrees, it means the other angle is 45 degrees. So, what are the ratios of sides on this triangle? If you have x, the other leg of the triangle is also going to be x, and the hypotenuse is going to be x rad 2. So now let's compute using our trigonometric functions. If I do sine of 45 degrees, what is sine again? So it's going to equal opposite over hypotenuse. It's going to equal x over x rad 2, or 1 over rad 2. But we know from our unit circle video that the sine of 45 degrees is rad 2 over 2. So what's this? Why are they different? Well, as a matter of fact, they're not. 2 is equal to rad 4, and rad 4 is equal to rad 2 times rad 2. So therefore, I can rewrite this as rad 2 divided by rad 2 times rad 2. And if I cancel these out, I'm left with just 1 over rad 2, which is exactly what my hypotenuse is. Okay, one more thing I want to show you guys. It's what's called the Pythagorean triples. Okay? So, a Pythagorean triple goes like this. If one of my legs is 3 and one of my legs is 4, I automatically know that the other hypotenuse is going to be 5. That is an example of a Pythagorean triple. A 3, 4, 5 right triangle. Okay? So whenever I see one side is 3 and one side is 4, I know the hypotenuse is 5. However, do not get confused here. Okay? If I see one leg is 4 and another leg is 5, that does not mean the hypotenuse is 3. Why not? Because the hypotenuse must always be the longest side out of any triangle. Okay? No leg can ever be longer than the hypotenuse. So in a 3, 4, 5 right triangle, 5 must always be the hypotenuse. Another Pythagorean triple is the 5, 12, 13 right triangle. Same thing applies. 13 must always be the longest measure, must be the hypotenuse, okay? So let's do some practice determining the angle measure on these triangles, okay? Let me rewrite this so that it accurately reflects the 3, 4, 5, okay? So let's say I wanted to find this angle. Well, there's lots of different ways I can take this. I could use sine of theta, which would be so opposite over hypotenuse, in which case it would equal 4 over 5. I could do cosine of theta, which equals adjacent over hypotenuse, which would be 3 over 5. Or I could do tangent theta, equals opposite over adjacent, equals 4 over 3. So now, if I want to find theta, I'm going to, let's say, for example, use sine theta equals 4/5. Then, what I can do on my calculator is you can see above your trigonometric functions, you have sine raised to the -1. That is called inverse sine. An inverse sine works that if I take the inverse of sine of theta, that equals theta. Okay? So therefore, I can write sine inverse, I can take the sine inverse of both sides, equals sine inverse of 4/5, and I'm left with theta equals the sine inverse of 4/5, and that is something I can compute on my calculator. I'm going to do second sine inverse, and I'm going to put 4 divided by 5 inside my parentheses, and I get theta equals 53.1 degrees. So now I'm going to take that theta, and I now know that's my angle measure here. I know this side right here is going to be 90 degrees, and 90 minus 53.1 is going to give me the remaining angle measure in my triangle, which in this case, this one is going to be 36.9 degrees. Now this sine inverse, it works with any of the trig functions. You have cosine inverse if you chose to go the cosine route, tangent inverse if you chose to go the tangent route. Alright guys, that's pretty much all I've got for you today. As always, enjoy life.